we're going to try to prove that this equation is also an identity. So we have sine cubed of x plus the sine of x times the cosine squared of x all over the cosine of x equal to the tangent of x. So remember, the first thing I want to do is draw a little line down the center so that I know I'm not crossing over that line and doing operations on both sides of the equation. So looking at this, I'm going to most likely choose the more complicated or the more complex side of the equation to work on, which in this case is going to be the left-handed side. And I'm looking at the numerator, and I notice that we have a sine of x and a sine of x in both of those terms. So I'm going to start by factoring out a sine of x. So what that leaves me inside the parentheses would be a sine squared of x plus a cosine squared of x. And that is all over the cosine of x. All right, now I see a sine squared and a cosine squared. And again, anytime I see a trig function squared, I'm going to be looking at probably the Pythagorean identities. And when I look at that, I see that sine squared of x plus cosine of squared of x is equal to 1. So I'm going to be able to write the numerator as the sine of x, and then we have the cosine of x in the denominator. And now I can just look at my basic identities and see that sine of x divided by the cosine of x is equal to the tangent of x. And that verifies my identity. So once again, let's recap how we verified this identity. So the first thing we did was we factored out a common factor from the numerator. Next, we saw that the stuff inside the parentheses was actually one of our Pythagorean identities. We could change that to 1. And then finally, we recognized that sine of x over cosine of x was one of our basic identities, and we could change that to the tangent of x.